Okay, thank you very much. So if we again consider a complex system, that is more complex, not the complex in comparison with the first one. So if Ex is equal to sin x is the function, and suppose this is the system. When we say function is nothing but that is the system that will operate on the input in order to get some desired output. So what will be the solution here? In order to get the solution, just write here the same x will, and then solve it the function, you will get here the solution. Now if this is the equation, ax minus by is equal to c, 2ax plus b is equal to 9c, and we are interested in order to solve, then again define it, that is what are the variables, coefficients, and then write the number of the variables and put here the solve command. We will get here the result for the x as well as for the y. Now these commands can be considered in our program when we are going to design a system, because that system is nothing very small equation or the very small command. That will be like a thousands lines of the program. So in that one we can use these commands in order to solve these type of the problems here. Now if the equation is something like in this manner here, x cubed minus xy equal to minus 3, and this one, then again we have to describe the x and y, and we will solve, and we will get here the result. Now see the result here for the x and y. Here we have just increased the complexity of the non-linearity. It is a non-linear but static system. It is not dynamic system. We are just increasing the power here of the parameters, but again it is the non-linear, but it has no memory. Now the second thing, one is the nature of the system. The second is when we transfer our concept to the system, or when we are interested in order to implement the system, then what will happen? We have to use a processor either in the hardware form or in the software form. So we have to use in particular type of the number system, as we have discussed in the yesterday's lecture. So we have to follow a syntax for the number system. Either we can use here the single precision or the double precision. If we are interested for the double precision, then we will write here the double x. When we say the double precision, it is the 64-bit number precision, and it is a floating point representation. And floating point again has the two categories. One is user defined, and the second one is the standard. Standard is the IEEE 754 standard, having the 32-bit for the single precision and the 64-bit for the double precision. Naturally, we will describe some concepts related to the number system and related to the representation of the coefficient and the signal, but after discussing the concept of the signals and the systems here and the equations. Now, if we are interested for the single precision, then we will write here the y single x, that will convert the single precision number system, and the one. Basically, there are the two categories. One is the fixed point, and the second one is the floating point. Floating point is categorized into two categories. One is the float, that is user defined, and the second one is the standard, that is the single and the double, having this IEEE 754 standard. And fixed point is represented by the QM.N format, that is the M number of the bits to be used for the, and N numbers will be utilized for the fractional representation here. INTX, when we write this type of the command, means we are using here the integer of the signed integer of the 8-bit here, and naturally we can derive here the range, and it is the tutorial problem for us that we have to decide how the -1 to 8 to 1 to 7 becomes the range in the 8-bit signed 8-bit representation, and we will discuss it in the next class here. It is the tutorial for us. We will solve it. Now for the 16, same is true for the 16-bit also, that is the fixed point number representation having the 16-bit, and now the range will become this one here, and the command is int16x. Now integer arithmetic, suppose we are interested in order to process, these are all related to the some numbers. Now suppose we are interested in order to process some information, not in the text form, but that is in image form. Then first of all, that image, that information has to be converted into the matrix form. So how the image will be converted into the matrix form? For that one, we will use the command imread. This is just the example. Here the imread is the command that will convert here the image into the matrix file, and fmt is the format that will be followed here. And file name, the name of that file name of that image here. This is the description of the same which we have discussed here, and it will convert the image into the m by n matrix if it is the black and white. And when we are interested for the colored image, then for the color we have to use the three colors, that is the RGB, red, blue and the green. For those colors, the three matrices are required here. So the m cross n by 3 will be the array here. Now, if we consider here the ordinary differential equation, the solution of the ordinary ODE, ordinary differential equation. For the ordinary differential equation, there are different solvers depending upon the different methods. The commands which are used in order to solve the ordinary differential equations are the ODE 45, 23, 113, 15s, 23, 23t. These are the commands which are used in the MATLAB to solve the equation. They depend upon each space. That is the
Hello, Manish. Hello, sir.
Yes, sir.
Sir, please share it again. Your screen, sir. Some participant has been interrupted by sharing their screen. And all the participants are requested to please do not touch the present now option. It will interrupt the presentation of the speaker. So please don't touch the present now button of your Google Meet screen.
Dr. Suman?
Yes, sir.
I think I had given you the control. If the requests are not followed by the candidates, they should not disturb the others. They may be blocked. Okay.
I think mic also should be switched off for everyone.
Mic switch off. Dr. Suman, Dr. Manish, put the switch off mic of all the participants, huh? Except me, because
yes,
I have
yes,
to. So ordinary differential equation, in order to solve the ordinary differential equation, now it's okay. So ordinary differential equations, in order to solve the ordinary differential equations, you can use the different types of the solver depending upon the different methods. That is the Runge-Kutta method, Adams method, NDFs, BDFs. These are the different methods which are used in the methods to solve the differential equation. Now, depending upon these algorithms, these concepts, these commands are developed. When we use a command of the MATLAB, it is not just like a command, it is a program itself. Here, the basic kernel is the C. So, whatever methods are used in the Runge-Kutta, the same algorithm has been converted into the program using the C kernel, and the program has been formed in the form of the command. So it is very useful, very interactive for us without any complexity here. Now, again, these are the some evaluation and extension. These commands are used for the evaluation and the extension here. And solver options had the OD set, ROD get. Output functions, these are the output function. Again, that is the ODE plot. This will be time series plot, and if we are using the ODE phase 2, this is a 2-dimensional. For the 3-dimensional, we have to use the phase 3, and ODE print for the in order to print the command window here. ODE means ordinary differential equation. Now, the first order or the second order ordinary differential equations may be considered here for the different purposes. MATLAB solvers handle the different types of the ODEs, like the explicit ODEs of the form y dash is equal to, that is a function of y dash, that is the first derivative, function of the time as well as the y. And now it is in matrix form, that is the ODA implicit ODE, that is the m ty y dash. Y dash will be multiplied by a matrix here. This will become a function of the fty. If this is the format, that is the here the implicit ordinary differential equation, mty is a matrix here. And fully implicit, that is the function of the time y factor and the y dash first derivative. And higher order of the differential equation. If we have the higher order ordinary differential equations, then those higher order differential equations will be converted into the first order, and then we will solve it. For example, if there is nth order of the differentiation, then this may be also written as we used to write the different differential equation, that is the y1 is equal to y, then y dash will become the y2, that is the first derivative, and so on. Now this may be written in this form, and now we can generate a matrix, and we can rewrite the, here we can consider example of the van der Pol equations here, and we can solve that one using these commands here. Now if we are interested in order to describe the result, and results has to be visualized using the color, then for that purpose we have to use the color map having the complex grid. So here the complex map plot or the color map has to be used. In the color map we have to use the HSB model here. So here if we write here the color map HSB, and this is the value of the HSB model here 64, and the complex grid for the gridding purpose, and here the complex map of the Z and Z plus. Now the title will be, as we have discussed in the study lecture, that title may be entered here. The title will be the Z. Now see, these are the commands which will be written in the MATLAB command window, and this is the return of the result. And now if we are increasing the complexity, that is Z to power 3, here we have described C. If we just write here the Z to power 3 without this, the description of the Z, then there will be a error, because the Z is a parameter which has to be defined first, then we have to define the equation here. Now if we use here the fz, that is a function of the Z to power 3, then for that purpose we will just use here the same command, that is the complex map Z and Z to power 3, and here using the power we are using the dot command because it is a vector, and there may be different elements in the rows and columns, so we have to use the dot then operator as we have discussed in yesterday. And the title may be written, whatever may be the title we are interested, that may be written here. Here we have just written that Z to power 3, so this is the title and this is the graph here for this one. It is for the Z to power 3. Now if it is Z to power 4 minus 1 and its whole power is 1 by 4, so 4 zeros at the fourth roots of the 1 will be achieved here. That is, this is the function here, Z to power 4 minus 1, its power 1 by 4, and we will use here the complex map title, and this is the result, which can be graphically visualized and analyzed for the different purposes here. Now if we consider here the fz 1 by z, a simple pole at the origin, then here the three-dimensional plot of this one, that is the simple pole at the origin, here may be described by this one. Now if we consider here the a10 2z branch cuts, here the similarity is at the plus minus j by 2, then the same command, and this will be the graph here. Now the view may be from the different sides. It may be viewed from the negative imaginary axis. Here we will define the auto axis, a complex root, and this will be the from the negative side. we are taking the view of this one from the negative side, having the z to power 1 by 2. Similarly, it is true for the z to power 1 by 2 using the here the Riemann surface, and again it is for the Riemann surface again here. Now we are just coming to the MATLAB here. These are the some glimpses or some aspects which we have described using the commands. Now we are coming to our actual motive. When we double click on the MATLAB command, then there will be a window, and if we are interested for a particular field and we are not aware about the concepts of the MATLAB, then we should move to the help. Here, when we click on the help, then we will find the different options here. There will be one product help. When we select the product help, then we'll find this type of the description. Now if we see, then we'll find the first one is related to the release node. Second one is related to the installation. Third is the MATLAB. When you click the MATLAB, there are so many fields of the MATLAB, and the same is true for each and everyone. Here the MATLAB, when we say MATLAB is nothing but this describes the concept of the .m file. So far we have discussed only the concept of the MATLAB. Means how the commands will be utilized, what are the roles of the different commands, and how those commands will be arranged in order to make a program, and that program will be saved as the .m file. For example, if we are interested in order to design a thermal tank, suppose we write it save as the thermal tank .m, like that. The extension will be the .m here. The next one is the toolbox. Toolbox, when we select a toolbox, a dialog box will be opened. According to our field, whatever is our field, we will select a toolbox, and in that toolbox, a dialog box will be opened, and dialog box requires the different types of the information, like a teacher. As a teacher asks so many questions during the time of the Viva, practical, or the classes to the students, and a student can respond only when he has gone through the topics. So when we are interested in order to design any system using the toolbox, then the basic requirement is that we must be clear about our theoretical concepts. Only then we can respond the different questions of the dialog box here. And when put the different parameters of the dialog box in order to design a system, then and we select here the design, then the system or the process will be designed according to our choice or according to our field. And there are so many options of the analysis. After designing, we can analyze it. Means what will be the result, like what will be the pole zero plot, whether it is stable or not, whether what is the frequency response, like that. What will be the output when it will be disturbed by particular type of the input, that is known as the signal, test signal. Suppose we give a test signal, then what will be the response? When it will be excited by this signal, then what will be the response? That can be tested, or that can be analyzed after designing it. And after a detailed analysis, by providing this type of the signals, we can decide whether we are in the satisfactory domain or not. There may be a deviation that is known as the error. So we have to also analyze whether this range of the error is in the permissible range or not. If it is in permissible range, it's okay. Otherwise, there is a need of the modification in the designing. So how the designing will be modified? Again, we will move to the toolbox with our experiences, with our knowledge, and then we will try to improve the our designing. And again, we will analyze and move further here for the purpose of the implementation. These all are related to the design and analysis of the system. So for example, if we see, then we find there is the toolbox, aerospace, bioinformatics, communication toolbox, control system toolbox, curve fitting toolbox. as sir was asking and somebody asking some another your participants were asking about the curve fitting. Now see, curve fitting itself is a ocean. These are not a single title, but they are the ocean, the field of the specialization. And database toolbox, here the data feed toolbox, here the economic tricks, that is the economics related to this one, embedded system, filter design toolbox, filter design HDL coder, how we will generate the VHDL code, and financial toolboxes for the management and the financial purposes here. The financial derivative toolboxes, fixed income toolbox, fixed point toolbox, that is related only with the fixed number system, and fuzzy logic toolbox, global optimization toolbox, image equation toolbox, image processing toolbox, instrument control toolbox, mapping toolbox, MATLAB building and MATLAB builder, any MATLAB compiler, MATLAB distributed computing server, MATLAB report generator, and here the model predictive control toolbox, neural network toolbox, optimization toolbox. Now see some more toolboxes here. The parallel computing toolbox, partial differential equation toolbox, RF toolbox, radio frequency, robust control toolbox, signal processing toolbox, sim biology toolbox, SP line toolbox, signal processing line, and spreadsheet tool link, and the statistics toolbox, symbolic math toolbox, system identification toolbox, system test. These are the toolboxes in which we will face some dialog boxes, and by providing the information we can design our system. So there are the two steps. The first one, in the MATLAB we can use the .m file. .m file, in order to write the .m file, the two types of the informations or the two types of the knowledge are required. One is we must be aware about the concept of the command, and before that we must be aware about our subject of field. Now the same is true for the toolbox, but toolbox can help us like a teacher. Like as a teacher in tutorial gives you some assignment, then teacher guides you to solve the problem. Similarly, the toolbox will guide you whether you are giving the right answer or the wrong answer, whether your design model is satisfactory or not. It can be visualized here without using any command, without using any program. But it is advisable to write the program. Why? Because there are the certain limitations, and whatever are designed, whatever the limitations, whatever concept and methodology have been adopted in the toolbox, we are bounded to follow that one. The next one is here the Simulink. Simulink describes the block diagram. Suppose we are interested in order to design a system. So in order to design a system, the first step is describe the concept. Then that concept is broken into the smaller blocks, and then sub blocks are developed. Then on the basis of this block diagram, we can design the system. And these blocks are available in the Simulink function library, or sometimes we can generate our own blocks here. How we can generate? For example, if we are interested in order to generate a particular filter, then first of all we will design that filter using the toolbox or using the .m file, and then that will be converted into a form of the block. And now you can use that block as a design filter for the purpose of the signal processing or for any purposes here. So in the toolbox here, the Simulink, we can use the block diagram. And again, when you will select the block diagram, then during the time of the selection of the block diagram, you must be aware about the concept. It is not a random that we can select any block from here and there just connect to this one. You will find so many types of the S parameter error. So many errors will take place here. So for the purpose of the learning, we have to follow the three steps. One is for the MATLAB.m. The second one is toolbox, And the third one is the Simulink, that is the block diagram. That is also, it is related, block diagram is related to the aerospace block set, communication block set. There are so many fields, as we have discussed in the previous one. The same is true for the now, when you select a particular toolbox, or even you select the MATLAB, then in that one you will find so many examples, so many demos, so many concepts. So what we have to do, first of all, we have to decide our field of working. As we have discussed the basic features, that is, now we are at a platform from where we can move in any direction, but direction has to be decided by you. So in that direction in which you are moving, you have to be updated for the purpose of the designing here. Now we are just considering here some example in order to revise our concept here. Suppose we are interested in order to generate the square wave with the help of the sine wave, as it is named as the Fourier series. Fourier series says that any information can be represented with the help of the another informations or the vectors, provided these are orthogonal to each other, that is independent to each other. Now, if we are interested in order to represent any information with the help of the another vectors, or any vector information with the help of the another vectors which are orthogonal to each other, then if we assume in the real world, then there are the 3 dimensions, and at each and every point we can get a vector that is orthogonal to each axis here. So we can say that there are infinite number of vectors which are orthogonal to each other. So in order to represent any information in another domain, infinite number of the vectors are required. Suppose we are interested in order to represent any square wave using the sine waves, odd harmonics of the sine wave, then how many odd harmonics of the sine waves are required? Infinite. And infinite number of the vectors, digits and functions cannot be used in order to design or in order to describe any concept, because during the time of the processing it is impractical here. So the approximation takes place, and in particular this case it is named as the Gibbs phenomena. We are just trying to display the Gibbs phenomena here. Suppose this is the sine function. We have started to describe the sine function, that is the having the 0 to 10, having a uniform gap of the 1, and point 1 here that is point 1, and function is sine t, and plot x comma y. Now see the graph here, you will get this one having the uniform gap of the 1. And now suppose we again include here the harmonic, third harmonic, odd harmonics are included here. Here this one, that is the 3t, third harmonic, and then again plot the t comma y. This is the approximation of this one here. Now again we include here the first, third, fifth, seventh and ninth harmonic, and describe the function having the same range of the t. We will get this type of the function here. Now suppose we have increased it by a value of the 19. So here by increasing this one by a value of the 19, we see here the same can be represented here using the command. Now we have arranged these commands in a particular manner to get the result in order to describe the Gibbs phenomena. It is not just example, it is just a very simple example of the program in which we are using the commands here. And now this will become, this can be saved as the .m file here. Now see, this is the result of the Gibbs phenomena. Here it describes that approximation is there here during the time of the description of the square wave with the help of the sinusoidal wave here. Now it can be also represented using the here the shading of different colors, which is more easy to visualize and to analyze the concept here. We are just using here the surface plot, which we have discussed in the previous lecture. So just write here the surf y, and we will get here the shading of this one. Now these are the description about the shading color having the different syntax or the different types of the commands here. The different types of the commands are used for the different purposes, like the flat shading, interpolated shading, and faceted shading, and the shading having a vector of the AX in which the X is replaced by the AX. and shading is an M file. That M file, it is also a program that converts the information in the here the colored shaded form for the purpose of the analysis and the discussion here. Now again, if we consider here some more example review of the signals, like the continuous analog signal, which we just used to test our design, whether we are in the electrical field, electronics field, mechanical field. First we design the system, and then these systems are tested by the different types of the disturbances. And which type of the disturbances are more suitable for the testing of the signal? Having the sudden change, like the step, and the next complex one is the impulse or the pulse. Having the first change from 0 to some value, and again 0 to some value to the 0 here. Means we have to test our, and if we see the pulse here, then we will find that here the value is changing from 0 to some value, say 1, and then it remains 1 for a particular duration, then again becomes the 0 here. So if we see, then we will find the two ranges of the frequency. One is the here the in the 0 time, the value is changing, the test signal value is changing from 0 to a particular value, that is infinite frequency. 0 in 0 time there is change, so infinite frequency, inverse of the 0 will become the infinite frequency, and for certain duration it remains same, that is related to the 0 frequency, again there is related to the infinite frequency. So what is happening here? We are testing our system in two conditions. One is in very adverse situation, when it is changing its position, and the second one is in the best position. So whether the system, whether the personalities, these are tested in the two situations. One is the adverse situation, and the second one is the best situation. So whatever we have designed our system, that system will be tested using here this type of the test signal. Now we are just trying to discuss some concept of these test signals, so that we can utilize them for the purpose of the testing here. As we know, signal is nothing but that one is a physical quantity that may change with respect to time, space, one variable, more than one variable, and it conveys the information. And it is utilized for the purpose of the excitation of a system, and due to the excitation, whatever is the output, that is known as the response. And we analyze the performance of the system on the basis of the input, that is the excitation, and the response achieved here. And the system performance is nothing but that is a type of the signal processing. Algorithm is signal processing, means it is, when we say signal, it is not related only with the electrical and electronics. For example, if sun rises, some rays are coming, temperature is increasing, that is also a signal. If whatever is happening, if there is change, if there is quantity and energy that is changing with respect to any variable, that becomes the signal here. Now here we are just coming to the point that the signal maybe is continuous or the discrete. We are just skipping this one. Now, as we know, if the system is in analog domain or the continuous domain, then that one is represented by the x of the t. Means it is true for each and every time, having a range of the time, but it will be discretized. That is, the system will not exist for each and every time, but it will exist for a certain duration here. And this discretization is done with the help of the sampling, which is covered in the electronics field. And the advantage of this one, that now the processor or your system will not work for each and every time. So there is a multiplexing can take place here. At the same time, the different happenings or the different signals may be processed by the processor here. And the frequency of the sampling is just inverse of this one. We are just skipping these portions. Again, coming to the here the signal. Suppose we are using here the sinusoidal signal. Then for the sinusoidal signal, we all are aware of this concept, that is written by the amplitude, sine, some multiplied by some frequency, and t, then phi phase difference here. Now, it be use any MATLAB code for the sine signal here. See here, we have described the equation. Now see the value of the xs, fs, phi, and the initial time, step of the time, and the final time is given. So the t vector will be described by the t1 to 3.128. So here if we use the xs values of the xs fs, just write here and describe the time vector, and then write here the equation. This is the revision of the previous lecture here. The x will be represented by this one, and then plot x comma y, and we can put here the title on the x level and the y level. Now see here the result. We are just describing here this function here, and we have also introduced here the title in the form of the equation here, what we have described in the previous slide, and grading has taken place here, the grid on. Now if we are interested in order to generate the sawtooth, then for the sawtooth, very simple function that is again described here, the frequency of that one, that is the f of that signal, and the range of the t or the t vector, and write down here the sawtooth, and you will get here the sawtooth. Same is true for the rectangular or the square wave also here. For the square wave, we can use here the square command, and we will get the result here. Here if we are interested for the aperiodic signal, like the one command is the Gauss pulse that generates a Gaussian modified sinusoidal pulse, and chirp, it is related to the Y signal that generates a linear strip frequency cosine signal. Then here this is the related to this one, the chirp function generates this one here. And the second one is it is the Gauss pulse, and for the Gauss pulse we have to just write here the one command, Gauss pulse, and in this one we have included one command, that is the chirp here. The pulse train of pulses can be generated here like in this manner, that is a decaying function here. Pulse train is a decaying function, and we can generate this one in order to test any system having the here the amplitude. In this one the amplitude is decreasing here, that is the loudness is decreasing here. Now the sync function that is known as the sine r by r or the sine x by x. For that one, if we are interested in order to generate a sync function, then we have to write just here describe the x, range of the x, that is -5 to 5, and then put here the sync of the x, plot x comma y. You will get here the plot. Similarly, Dirichlet function, for the Dirichlet function, we all are aware with the Dirichlet function here. For that one, in order to generate the Dirichlet function, we have to use only this one here, that Diric command here. And if we see, then here we are increasing the value of the c here, then here these pulses are increasing here. In this case there are the 7, and in this one there are the n is 8 here. Here again the same is repeated here, which we have described. Now suppose we are interested in order to describe this type of the function, x e to power bt. Nothing is special, just describe here the value of this value here, the x e, what is the value of the t, what is the range of the t, that is the t1 to t2, and having a gap if we are interested. But in this case we have just written here the t1 to t2, that is by default it will take the gap of the 1, and then we use a command. Previously we have used the command plot, and plot just gives a plot between the x and y, f plot for the function. So when we write the f plot, then we have to describe the function and its range also. And in between the range and function, what is this one? If we recall, then we will find that it is the line specifier. And line specifier describes the line style, line color, and the line marker. So here we have used that dash, that is solid line, with no color, that is the blue in color here. So this is the description of this signal here. Similarly, if we are interested to generate the unit step signal here, then unit step signal can be generated mathematically. It is described as 1 for the positive value of the 0 when the time 0. When the time is negative, it becomes 0. That is, it is a feasible signal. So if any signal exists for the t is less than 0, then that is known as the anti-causal. Here this is the causal signal here. So for that one, again we describe the value of the x range of the t from t1 to t2, and f plot command will be utilized here, and then we will use here the label here the title on the x level, y level, and title of the total graph. And here the ranges of the x-axis and the y-axis. This is the step function here. Similarly, if we are interested in order to generate the pulse signal, then we know pulse signal is described by this equation, that is, it has some value in a very small range of the time, and ideally it is considered as it has the value of the infinite when t is equal to 0. But practically it is not true. That's why we have considered here width of the time here. And now if we can describe this one by this one, again the same is true here. Describe the t, use the f plot, and you will get here the result. Now see the result having a width. Now causal signal, suppose this is a signal here, this is a signal that exists for the t equal to 0 negative as well as the positive here. So when this signal will be multiplied by the steps function, then automatically this will become here the causal signal, because previous to this one, the t is equal to 0, this will become here the 0. So that's why we have used this concept here, that we have described the different concept here, the b, a, f, phi, t, and then we have considered the x is equal to b e to power this function, and then multiplied by step function here, and after multiplication it will be converted into the causal signal. So whatever are the required, which type of the signals are required for the purpose of the testing of any system, we can generate it as we have discussed the different type of the commands. And as we know, in the signal system or in any type of the system which we are interested to design, first of all we have to design the algorithm. Then the algorithm has to be tested, and how the algorithm will be tested or how the system will be tested by giving some type of the excitation or the input or the disturbances, and these excitation disturbances can be modeled based on the concepts which we have discussed here. Similarly, here exponentially decaying function, that is the stem function, discrete function here. So we have to describe this one, and we can use here the stem. We are using only one command, that is stem. Stem is used for the discrete purposes here. And unit impulse function, we have already described this one. And causal sequence, this is a sequence in which when we multiply this one, these two, this is the causal as well as the anti-causal, and we multiply this one unit step in the discrete domain. And we have discussed this one in the analog domain. Same is true here also, that is using the stem function, we can generate here the causal sequence in MATLAB. One more concept is related with the quantization. As we have discussed so many times, the quantization is required for the purpose of the implementation. That depends upon the processor's word length during the time of the software or the hardware implementation. Now the digital signal can be generated here. First we generated the here sinusoidal signal, and then including the stem we can generate here the digital signals. Random signals can also be generated, as we have discussed the command of the rand. So whatever is the size, we can generate m cross n or the n cross n. Depending upon the requirement, we can generate here the signal. So in the next lecture, we will discuss about the concept of the systems. And after tomorrow is gap, but deliberately I have put this gap. Basically, this is not a gap. This is a submission, a request from my side, that whatever we have discussed here, we have to cover this one tomorrow, and day after tomorrow again will be in the class, and that class will be an interactive class like the workshop. And in that workshop we will do here, and whatever will be done by the here at this nodal point, you have to do at your laptop or the mobile also. If possible, please arrange MATLAB from anywhere, because we are not the provider of the MATLAB. But if you have any facility of the MATLAB, you can download it, because in this pandemic situation, the MathsWorks is also giving some free facilities. You can access some toolboxes or some facilities of the MATLAB. So please go through those facilities, and again we will come on day after tomorrow, and that will be the zero level. Now we are just moving towards the zero level. Presently we are not at the zero level. Day after tomorrow we will be on zero level. Only when when we will go through each and every concept whatever we have discussed yesterday and today. Only then we will be at the level of the zero day after tomorrow, and then we will start some new journey for the other practices. So thank you very much. And if you have some queries, as some queries were raised yesterday, we have discussed in the just starting of the session. And if you have any general question or the queries, because the MATLAB is very it is not a very small ocean. It is the larger than the largest ocean. So whatever we are trying, just we are taking 1 or 2 drop of water from that larger than largest ocean. So try to try to just understand our concept for which we are with you. We are just trying to discuss the concept how we can use the MATLAB in order to design and develop our system. So again and again, the request is submitted that please go through these steps, these discussions, and day after tomorrow we will be again in the class.